Hello, I hope you are great. We'll continue with our lessons of mathematics. I'm explaining the last questions that I sent. Okay, the first three terms of a geometric progression are there's 1, 2, and 3. This is the first term, second term, third term. Okay, three terms. Terms are separated by commas, so it's one comma and this and that. You have three terms. The first question is find the value of x. Now, since they've explicitly told you that this is a geometric progression, by now you must know what to do, right? If I have, for instance, 2, 4, I have 8. Just for the sake of recap, to clarify, if you missed it when I explained last time, okay? What is happening for me to get to the second term? I've multiplied 2 by 2 to give me 4, right? From 4 to 8, I've done what? I've multiplied 4 by 2 for me to get to 8 from 4, okay? And therefore here, the rule is simply to multiply by 2. Multiply by 2 for me to get the next term. So if I'm to get the next term here, the fourth term would be what? This times 2 to be 16, okay? So if you're dealing with multiplication, for the most part, get this point, for the most part, you may find that you're dealing with a geometric progression, and at your level, this is what is happening. There's a part to do with multiplication, and that is why there's this formula that you come up with, where you say, you get the term we're looking at, which is 4 in this case, dividing by the previous term. I'm going to get what? I'm going to get a 2, right? If I'm looking at 8, I divide it by the previous term, which is a 4 here, I'll still get a 2. If I get 16, dividing it by the previous term, which is 8, 16 dividing by 8, I'll have, so you see there's 2 here throughout. The 2 is what we call what? R, which is the common ratio. It is common throughout. Okay? And therefore, from this we can simply say 4 divided by 2. Since 4 divided by 2 has given us 2, and the 8 divided by 2, we can simply say 4 divided by 2 equals 8 divided by 4, right? Because the answer will be the same. They're giving us 2 in each case. This is 2. Equally, this is what? 2. So that's why we use this. And if I'm to get the first term, I can equally equate to the third term, or to whichever term I'm dealing with, okay? I can also say 4 over 2 equals this one here, 16 over 8, because the answer is the same. This will give me 2, this will equally give me 2. So it is from this that we have this equation now. And it is the equation that you should understand, because it is almost always there in paper 2 of maths. This is a day in, out, for the most part, you find it. You need to apply it. You need to know how to apply it. So here, they have given us the first, second, third term. And since we've identified the fact that it's a geometric progression, and they have even told us, we can simply say, it's our first term here, x plus 1. Then this is our x negative 3. And we have x negative 1, like that, okay? Now, from what I gave, where I had a 2, let me not even do this anyway. Let me just do this. First term, second term, then third term. Okay, so the term I'm looking at is this, right? So I can simply say R, which is the common ratio, equals the term I'm looking at, which is x negative 3, dividing by the previous term, which is x plus 1, equals the term I'm looking at, which is x negative 1, dividing by the previous term, which is x negative 3. You get it? Having done this, we can now find the value of x. These we equate, so we're going to have x negative 3, this multiplying by that, equal to this multiplying by that, which is x plus 1, x negative 1. Okay. So this will give us what? X times x, which is x squared. Whatever I have here must multiply with everything here. So x times x, x squared, then x times negative 3, that will be negative 3x. Negative 3 times x, that will be negative 3x. Negative 3 times negative 3, that will be what? Positive 9. Negative times negative, that will give us a positive. Equal to this times that, which is x squared. And again, x times negative 1, that will be negative x. We come here. 1 times x, that will be positive x. Then 1 times negative 1 will be negative 1. Okay. We move on. We collect like terms here. Okay. So we have x squared. This can come here. So from being positive, it crosses the equal sign to be negative x squared. Then here you have negative 3x, here you have negative 3x. The ideal here is to have letters here, the numbers other side. That's what I usually like doing. It makes the work easier and even much easier for you to follow. So let's bring the letters here, then the numbers other side, okay? So this will come here. Oh, it has already come. This is already here. Then this coming from this side, crossing the equal side, crossing the equal sign to be from negative to positive x. And equally this, crossing the equal sign to be negative x, since it's positive here, which equals it. Then the 9 will come here. From being positive to be negative 9, then you have negative 1 there. X squared minus x squared, in short, this will cancel to give us 0. Negative 3, that will be negative 6. Always keep the sign. Negative 9, negative 1, then you have negative 1 here. So negative, okay. So you can do the math here. This and that, we equally cancel. No, this is negative and negative. So that will be negative 6. Okay? Negative 6x, then plus x, that will be negative 5. Then negative x again. So in short, this will cancel. We're going to have negative 6x being equal to what? This and that to give us negative 10. Negative 9, negative 1. So this is dividing by negative 6, negative 6. Therefore, x equals 10 over 6, which can be written as what numbers can go into both without leaving a remainder? 2, right? So we're going to have 5 over 3. Therefore, x equals what? 5 over 3. So we found the value of x. The second question is find the first term. So the first term is here, which is x plus 1. And we found x to be 5 over 3, right? So simply substitute where this x, we put 5 over 3. Plus 1. This is 3. 3 here is 1. 3 into 3 is 1. 1 times 5, that is 5. Plus 1 into 3, that's 3. 3 times 1. That will be 8 over 3. So this is our first term here, 8 over 3. You can leave your answer right there. Okay. So we found the first term. Now they're saying find the sum to infinite. The formula that you use when finding sum to infinite. Sum to infinite equals a over 1 minus r, which equals, what is our a? Our a is the first term. This is a here. So the first term is what? 8 over 3. Okay. So we're going to have 8 dividing by 3. This is the a. Then this means division, right? A is this. So here simply saying dividing by 1 minus r is the common ratio. Okay. And what is the common ratio? The common ratio is, let's get back to what we have. We have x plus 1, we have x negative 3 as second term. Okay, so R equals the term I'm looking at, which is x negative 3 dividing by x plus 1. Okay, that's the previous term. So x plus 3, x is what? 5 over 3. So you have 5 over 3 there, minus 3. This means division here. We are dividing this into that. So this is this here on top. Then, since this means division, I'm going to have the division symbol there. Then I'll have x. What is x? X is 5 over 3 plus 1 there. Okay. And therefore that equals what? 5 over 3 minus 3 over 1 dividing by 5 over 3 plus 1 over 1 like that. Okay. Any number is as good as that number divided by itself, because nothing will change. For instance, if I have 5 over 1, that is 5. 9 over 1, that is y. Therefore, we say any number divided by 1 is equated to the number itself. Nothing changes. It is equated to the number itself. Okay, so this will equal what? Common multiple there is 3. 3 into 3 is 1. 1 times 5, that's 5. Minus 1 into 3, which is 3 times 3, 9. That gives us 5 minus 9, that's negative 4 divided by 3. Then dividing by, here the common multiple, 3. 3 into 3, that is 1. Then times 5, you have 5. Then plus 1 times 3, which is 1 times 3, that is 3 times 1. So I have 3. In short, this will give you what? 8 over 3. So negative 4 over 3. Then this must be changed to multiplication. You multiply. Then what you have here will be changed. What is down will be on top. So I'm going to have 3 over 8. And therefore this gives us what? You can say 4 here 2, 4 here. You can say 4 here 1, then 4 here 2. So 1 times 3. 1 times 3, that would be 3. Then dividing by 3 times 2, which is 6. So you have 3 over 6. Now check. This is negative here. But negative. So this will be what? Negative 3 over 6. Which can be simplified. 3 into 3, 1. 3 into 6, 2. So we have our R to be equal to 1, or you can say negative half, negative 1 over 2. Okay. Now the formula is this. We are finding the sum to infinite. Okay. Sum to infinite. Which is A over 1 minus R. In short, this means A dividing by 1 minus R. What is our A? We found our A to be 5 over 3. No, that's X. Our A is 8 over 3. Okay, that is the first term that we found. So here we have A, which is 8 over 3 dividing by 1 minus, what is our R? Our R is negative half, right? So we have negative half like that. So we can do this here. Okay, this would therefore be equal to 8 over 3 dividing by this and that. It will become positive, negative and negative. So we're going to have 1 plus 1 over 2. And if you add this, you have 3 over 2. This would be 8 over 3. Then times what you have here, 2, then to be reversed. What's down and on top? 8 times 2, 16. 3 times 3 is 9. Can't simplify this any further. Can leave your answer right here as a fraction. So basically that's it, and so I'll end in explaining the equations that I sent last time. Okay, so this is our answer, 16/9.